It's too late to avoid climate change, but we can still stop the worst of its impacts on our lives, jobs, communities, and the world we live in. The Intergovernmental Panel on Climate Change, or IPCC, is the global authority on the most up-to-date information and risk analysis of this challenge. It outlines the impacts of climate change, how we can adapt, and where we are most vulnerable in its 2022 February report. With this, governments and leaders can choose how to act to protect us in future. Professor Catherine Bowen, one of the lead authors, says many risks for human health and well-being could be reduced and some potentially avoided if we reduce our greenhouse gas emissions and strengthen our adaptation responses. So, what are the risks, and how do we prepare for those we can't avoid? Reaching 1.5 degrees Celsius of warming before 2040 will cause further serious and complex threats to our ecosystems and communities. This goes far beyond worsening extreme weather events like flood, drought, and fire. Climate change will also worsen issues that already exist, such as social, economic, and health inequalities. Financial and emotional stress from drought and other disasters can lead to far-reaching effects through rural communities. And extreme heat has already increased global rates of many illnesses. In Australia and New Zealand, the IPCC identified 9 key areas of risk, including coral reefs, alpine biosystems, certain forest types in the south, kelp forests along our southern coast, sea level rises in many coastal areas, agricultural production in much of the country, heat-related death and disease, other complex impacts on our cities, and the inability of some institutions and governance systems to manage climate risk. The report also identifies 127 future issues that will get worse for every fraction of a degree of warming above 1.5 degrees Celsius unless effective changes are made. In agriculture, warming threatens to weaken soil health and increase pressure from pests and disease. Droughts, floods, and heat waves reduce crop yields, making food more expensive and difficult to access. Much of this can be avoided or lessened if we reduce emissions and limit warming. Below 1.5 degrees Celsius, many animals and plant species should be able to adapt to a changing environment. For example, below 1.5 degrees Celsius, sea level rise will be slow enough to give mangroves time to migrate to livable conditions near a new coastline. And that's especially important in places like Northern Australia, where mangrove forests protect people and infrastructure from worsening disasters such as floods or cyclones. Being ready for a changed climate is just as essential if we want to avoid loss of life, biodiversity, and infrastructure. Indigenous peoples also have crucial and unique knowledge and experiences to offer and must be central to decision-making processes. From technology solutions through to simple changes in how we plan future cities, there are many actions available for governments and leaders to put in place to make a difference. The scientific evidence is undeniable. Climate change is and will continue to cause harm to human well-being and planetary health. Any delay in both reducing emissions and addressing the impacts of an increasingly changed climate will mean we will miss this chance to secure a livable and sustainable future for us all.
The Australian Academy of Science, because questions need answers.
Welcome everyone, and thank you for joining us. I'm Professor John Shine, President of the Australian Academy of Science. I would like first to acknowledge and pay respect to the traditional owners and their elders, past and present, of all the lands on which the Academy and our fellows operate, live and work, especially the lands of the Ngunnawal people where the Shine Dome in Canberra is located. The Academy is committed to convening the very best experts on matters of national interest to provide independent evidence and improve scientific literacy across Australia. Last year, we released a report warning of the impacts of 3 degrees of global warming if more action isn't taken to slow climate change. And we also, of course, support Future Earth Australia to carry out its mission to convene leaders to advance Australia's sustainability agenda and help Australia make progress on the United Nations Sustainable Development Goals. We now have a lot of information about how the physical climate is changing and what will be the impact of this change on our lives, our jobs, our homes, and the ecosystems that we all rely on. Well, today, hopefully, we'll answer some of those questions. The Intergovernmental Panel on Climate Change, or IPCC, is widely regarded as the most important and authoritative source on climate change, its impacts, and how to tackle the rising emissions that drive it. Created in 1988, the IPCC is now in its sixth phase of assessment reports. The IPCC also publishes special reports on specific climate issues and other documents, including guidelines on how to appropriately report on greenhouse gas inventories. Now, already released as part of the sixth assessment report is the contribution from Working Group 1, who focused on the physical science basis of climate change. In about a month, Working Group 3 should publish their contribution on mitigation. And finally, a synthesis report is scheduled for later in the year. But yesterday evening, Australia time, the contribution from Working Group 2 was released, and that covered the observed and projected impacts of climate change, the adaptation capabilities of communities and biosystems, and the vulnerabilities that are posed to humans and to our natural systems. This report compiles risks, adaptation, and sustainability evidence for entire systems affected by climate change, from terrestrial and freshwater ecosystems, through to cities, settlements, key infrastructure, and the health and well-being of our communities. Then it outlines key areas of risk for geographical regions and provides numerous adaptation options that, if implemented now, could reduce and in some cases even avoid further harm due to an increasing changing climate. It closes with chapters on sustainable development pathways to integrate adaptation and mitigation. But how does this specifically relate to Australia? And what can policymakers and professionals do, both inside and outside government, to make use of this resource in support of the critical decisions they make? So today we're very fortunate in being joined by 4 of the Australian primary authors who contributed to Chapter 11 of the report, which focuses on Australia and New Zealand. Now, throughout this event, please submit any questions you have by scanning the QR code that's on your screen, or by going to science.org.au/Q&A and follow the on-screen prompts. We'll address as many questions as we have time for. So now I'd like to introduce our first speaker, Professor Brendan McKee. Brendan is Director of Griffith University's Climate Action Beacon. He's widely published in the fields of environmental biogeography, climate change impacts and adaptation, and forest ecosystems. Brendan is a coordinating lead author for the IPCC 6th Assessment Report and an author on the summary for policymakers. So we're very pleased to have you here, and thank you very much, and welcome, Brendan.
Thank you very much, John, and welcome colleagues. So, as you can see there, we're talking today about one of the chapters in the IPCC 6th Assessment Report, Chapter 11. It's called Australasia, but it actually focuses on Australia and New Zealand. And you can see we had an author team. I had my coordinating, there were 2 coordinating lead authors, myself and New Zealand colleague Judy Lawrence, and our team of lead authors, chapter scientists and review editors. And I'm joined by three of our lead authors today. And we're going to give you an overview on some of the key messages from this chapter 11 of the report. So chapter 11, it's not 151 pages. I think it's actually 102 pages. It's still a substantial document. And it has sections which address observed and projected climate change, observed and projected impacts from that observed and projected climate change, and also observed and predicted adaptation. And it does this by sector. We look at observed and projected climate change impacts and adaptation in those sectors on the right: terrestrial and freshwater ecosystems, coastal and ocean ecosystems, freshwater resources, food fibre ecosystems, cities, settlements, infrastructure, health and well-being, tourism, finance, mining and energy. So it was an attempt at a very comprehensive assessment. There's also some figures we've used to illustrate key points and boxes which give more focused attention to these key topics of wildfires, Great Barrier Reef, Murray-Darling Basin, flood risk and sea level rise, as well as a set of frequently asked questions. So between the four of us today, we're going to give you some insight into all of that chapter's findings. So to begin, I'm going to say something about the observed impacts and associated risks. So one of our, but to begin, I would like to also acknowledge the people who are the traditional owners of the land where I'm speaking to you from, is the Gold Coast, Queensland. Pay respects to their elders past and present, and extend that respect to other Aboriginal and Torres Strait Islander peoples. And the Gold Coast is situated on the land of the Yunganbay Kumberi peoples. This is a main high-level statement from our report, which is that, and this is observed impacts. Climate trends and extreme events have combined with exposure and vulnerabilities to cause major impacts for many natural systems and also many human systems, with some of the natural systems experiencing or at risk of irreversible change in Australia. And it's important to understand this distinction between what we call climate trends and extreme events. And in terms of impacts, a climate trend we can think of by a health analogy as a chronic impact, whereas extremes can give us acute impacts. So in terms of trends, we've seen in Australia further warming and sea level rise, with more hot days and heat waves, less snow, more rainfall in the north, less rainfall in October, April to October in the southwest and southeast, and more extreme fire weather days in the south and east. Let me just give you some of the highlights from the observed impacts. Unfortunately, I have to report that the bramble K. melomys, an endemic mammal species, became extinct due to the loss of habitat associated with sea level rise and storm surges in the Torres Strait. We've had extensive coral bleaching events and loss of temperate kelp forests due to ocean warming and marine heat waves, among other factors, which you'll hear more about from Professor Greta shortly. Some of our forest ecosystems have experienced unprecedented bushfire impacts. We've seen socio-economic costs arising from climate variability and change increasing. We've had extreme deaths, heat lead to excess deaths and increased rates of many illnesses. Droughts have caused financial and emotional stress in farm households and rural communities. Coastal flooding has increased due in part to sea level rise superimposed upon high tides and storm surges, and tourism has been affected by coral bleaching, bushfires and poor ski seasons. So the impacts from the observed impacts from the climate change we're now experiencing from 1.1 degree of global warming we've had since pre-industrial levels is very real, and it's evident right across the continent and right across Australian society and our economic sectors. Let me say something about the impacts from extreme events, because I think this is another, I think, of the high-level conclusions from the assessment, which is new compared to 2014, and that we've seen a increase in the frequency and duration and intensity of, or intensity of extreme weather events. So as we note here, extreme events such as heat waves, droughts, floods, storms and fires have had all these major impacts on households and communities and businesses our ecosystems. And perhaps there is no more, a very well documented example now is the 2019 and 20 Southeast Australian wildfire, the so-called Black Summer Fire. It burned up to 8.1 million hectares. 114 listed threatened species lost at least half of their habitat. 449 lost over 80% of their habitat. 3,000 houses were destroyed. 33 people killed. A further 429 deaths and 3,230 hospitalizations due to cardiovascular or respiratory conditions. There was 1.95 billion in health costs, 2.3 billion in insured losses, and 3.6 billion in losses for tourism, hospitality, agriculture, and forestry. So the ecological and economic and social costs of this change in extreme events is indeed significant. In terms of projected climate change, ongoing warming is projected with more hot days and fewer colder days, snow and in New Zealand glacier retreat, ongoing sea level rise in ocean acidification. Three major projections are more extreme fire weather is projected in southern and eastern Australia. Heavy rainfall intensity is predicted to increase with more, but also with more droughts over southern and eastern Australia, and an ongoing decline in winter rainfall in southwest and southern Australia. However, the degree of global warming and the associated increase in climate trends and extreme events and the chronic and acute impacts they have on our natural and human systems very much depends on the success or failure of the world community, of which Australia is a part, of global mitigation of greenhouse gas emissions. And in our report, we have endeavoured to capture this coupling or tight relationship between future climate-related risks and the level of global warming with what we call the burning ember diagrams. And I would encourage you to go to our chapter and have a look at these closely. Some of my other lead authors today will be speaking about these more, some of these key risks more specifically. But we've identified 9 key climate-related risks for our region. Some of these are natural systems that are, to use the common vernacular, at tipping points of irreversible harm. And we'll hear more of that in terms of coral reefs shortly. But we're also at a tipping point in terms of loss of alpine diversity in Australia due to snow loss and severe impacts for very specific of our forest types, such as the Tasmanian pencil pine and snow gum woodlands. Then we have some key risks where the risk is currently high and their future is uncertain, depending on the level of global warming we face, such as in the natural systems, kelp forests, and the extent to which we get further disruption and decline in agricultural production and further stress in our rural communities in southwestern, southern and eastern mainland Australia. And of course, we're going to see an increase in heat-related mortality and morbidity, depending on the level of climate, of warming, but also on our capacity to adapt and change what we do. And we'll hear more of that from Professor Rickard shortly as well. We also have 2 new kinds of risks, which we call implementation risks. One of those is cascading, compounding and aggregating impacts on our cities, settlements, infrastructure and supply chains. Due to this compounding and growing impact of the extreme events, as we look around us today with this mega flood event that we're now experiencing. And then finally, in light of those kind of increasingly complex, difficult cascading risks, there's also a risk, another implementation risk is if our institutions and governance systems prove to be unable to manage this growingly complex climate risk environment. So to finish, we currently face chronic and acute climate-related impacts now. We have risks which are already at climate risks which are already at a very high level. The extent to which others reach that level of high risk depend on two things: the extent to which we can collectively and significantly reduce greenhouse gas emissions, but also the extent to which we now start to implement robust and timely adaptation. So I'll stop there, and thank you very much.
Thank you, Brendan. A very sophisticated sort of compilation of the risks there. It's very impressive. So thank you very much. We'll now move to our next speaker, Dr. Francis Chu. Francis is a hydrologist with 30 years of experience in research, teaching and consulting, and currently leads the Surface Water and Basin Outcomes Research Group in CSIRO in Canberra. He's a member of several global and national water expert committees, and including being the lead author of the IPCC 5th and 6th assessment reports. Welcome, Francis.
Thank you, John, and thanks, Brendan. I do want to start by acknowledging the traditional owners, and I'm speaking here from Canberra in Ngunnawal country. So I'll move on and talk mainly about freshwater resources, but I'll also touch on floods and risks relating to fires. So we all know that freshwater resources is obviously an important subject because water is a cross-cutting issue. Water affects people, agriculture, industries, and ecosystems. Now you hear about the changes in rainfall that Brendan spoke about. So these changes in rainfall, it will be amplified in the stream flow. In fact, as a general rule of thumb, we hydrologists tend to say that a 1% change in rainfall will tend to be amplified as a 2 to 3 times percentage change in the stream flow. So the projected decline in cool season rainfall in southern Australia, especially when a large proportion of our stream flow also occurs in winter and early spring, will be amplified in the decline in water resources. So the median projection, driven by this reduction in rainfall, compounded by the higher potential evaporation, indicates, as you can see in the picture, a 20% decline in stream flow in southeastern Australia, relating to a 2 degrees global average warming, which we expect to see around 2060 or 2070. Now, I've presented here only the median projections. Unfortunately, we are crystal ball gazing in the future, so there is a large range of uncertainty there in the projections also, and this compounds management and adaptation challenges in water resources. We know we need to adapt to a hotter and drier future, but there is uncertainty around how much and by when. So another story here is the projections. You tend to see that presented like this as changes to long-term averages. But really, we feel these averages, we feel these impacts in long dry periods. And we all know we live in a highly variable climate in stream flow and in rainfall. So we'll continue to see wet periods like what we are seeing now in the recent years, and we'll see dry periods. But what the decline in the long-term average means is we'll have more frequent droughts and more severe droughts that we and the ecosystems then need to cope with and to recover from. So managing this climate risk and adapting to decline in the freshwater resources in southeastern Australia is a bigger problem. The region is already so heavily populated and is highly productive. So climate change really is compounding and exacerbating the already complex challenges of managing water for the many competing demands in the region here. So in the IPCC report, you'll find a box that we dedicated to talking about some of the aspects around drought, climate change, and adaptation in the Murray-Darling Basin as an example of adaptation in the Murray-Darling Basin. So there are some good news here, and there have been some positive attempts in adaptation. The economic, environmental, and social impacts of the Millennium drought, and perhaps also the projections of a dry future, have certainly accelerated significant water policy reforms. Most of us are aware of the Basin Plan, returning about 1/5 of the water to the environment, increasing share of water to the environment. There has been active water markets. We are enhancing water information provided by the Bureau of Meteorology. And there are many programs and initiatives to increase agriculture productivity and increase water use efficiency. So all these are positive adaptations, as they certainly help buffer the system against drought. But there are also debates around being careful that we don't do this in a maladaptive way, because we may be perpetuating unsustainable water and land use under ongoing climate change, or perhaps widening the gap between social inequality and equity of water sharing. There have been contestations on the level of success of the Murray-Darling Basin Plan. We report that in our box. In fact, you could say that the Murray-Darling Basin Plan is actually an example which illustrates the difficulties in integrating climate change science and projections into any management, in this case here, water resources management. Now, in any case, we know a lot more needs to be done with the projected decline in water resources here, the 20% number I spoke about earlier on, being potentially greater than the water that we have recovered for the environment. Now, the good thing is this is acknowledged by governments, industry, and communities, and there's certainly been a lot of ongoing efforts to further strengthen the knowledge base. But equally important, there is an urgent need to consider scenarios and adaptation options, and really to sit back and consider what future we want and what is possible in the basin under climate change. So the upcoming Basin Plan Review planned for 2026, any update, I think that's an opportunity for this, and also to establish mechanisms for climate change management. So I'll move on away from drought to the other end of the spectrum, talking about the changing flood risk. Now we know that a warmer climate will intensify the hydrological cycle. So high rainfall intensity has already been increasing. We can observe that, particularly in Northern Australia, and particularly for the shorter duration and very high extreme rainfall. And we know that extreme rainfall is projected to increase in the future, as Brendan spoke about also. So this will increase flood risks in built-up areas and in small catchments, because in these built-up areas, the high rainfall can quickly become flash floods, which are called pluvial floods. Now, flood response in rural areas is a bit more complex, because it will also depend on not only changes to high extreme rainfall, but also to antecedent catchment conditions. So you can imagine in the southern parts of Australia, we are less certain about the changing flood risk, because you've got a contrasting effect of having more high extreme rainfall, but then you've got a drying projections in the antecedent conditions, which I spoke about earlier. Now, there has been some good examples of adaptation, particularly around urban water sensitive design, managing floods, water quality, and infrastructure in a more integrated and more holistic consideration. So examples include stormwater management and recycling, ecosystem-based approaches to maintain floodplains and restore wetlands, and retrofitting existing flood control systems to attenuate flows. But in the context of disaster management, most of the adaptation to changing flood risk is currently still mostly reactive and, in fact, incremental in response to floods that we see and in response to heavy rainfall events. And I'll just finish off with this one slide talking about escalating impact of risk from wildfires. We know that the frequency and severity of dangerous fire conditions have increased and will continue to increase. In fact, this example is brought out in IPCC, and we got 2 pages in the report just talking about these specifically. Fires have cascading impacts on people, on economic activity, ecosystems, and species, with very significant consequences in this part of the world, which we are all too aware of, having had a fire season just a couple of years back. And I think I'll almost finish off here mentioning what Brendan, or emphasizing what Brendan talked about earlier, that we identified this new type of climate risk, that is the cascading, compounding, and aggregate impacts from multiple hazards. Fires in this case, floods I've spoken about earlier on, you got the droughts, you got heat waves. These have cascading impacts on settlements, infrastructure, and supply chains. In fact, this is the new reality facing our disaster management and emergency services communities. the good news is we are certainly more aware of this now. And I'll finish off on a positive note, noting that you've got initiatives like the Australian Climate Services, the National Recovery Resilience Agency, and the various drought resilience initiatives happening in Southeastern Australia. I think these are good positive steps that we can build on to help address the climate risk that we're talking about. And I've finished there, John.
Thank you very much, Francis. Certainly brings into sharp focus that old adage about Australia being a land of droughts and flooding rains, certainly exacerbated by climate change to a whole new level. So look, thank you again. And if I could just remind everyone to submit any questions they have for discussion after all the presentations, but using the QR code on the screen. So we now move to our next speaker, Professor Greta Petzel. Greta is a marine ecologist at the Institute for Marine and Antarctic Studies and is the director of the Centre for Marine Socio-Ecology at the University of Tasmania. She has deep expertise exploring the impact of climate change on natural systems, and she's a lead author for the IPCC Working Group 2 report and an Australian Research Council Future Fellow. Great to have you here and welcome, Greta.
Thanks, John. I'm speaking today from Nipaluna Lutruwita, and I'd like to acknowledge the Muwinina people specifically, but also the team of Indigenous contributing authors that contributed invaluable knowledge to sections of this report. So in addition to the lead authors that you saw on the front slide, there were also contributing authors, and 4 of those were Indigenous scholars. As Brendan highlighted, many of the 9 key risks as determined by the Australasian chapter were related to natural systems. Not surprisingly, one of these was related to the impacts already documented for our coral reef systems. We have seen 3 marine heat waves on the Great Barrier Reef from 2016, 2017 and 2020. And it's the accumulated thermal stress throughout those heat wave events that leads to bleaching. And if that thermal stress is maintained, leads to death of the corals. Recovery of coral reefs following those disturbance events is very slow. It typically takes at least a decade after each bleaching event for the very fastest growing corals to recover. Recruitment of corals, so the production of new corals, of baby corals to try and replenish these systems on the Great Barrier Reef in 2018 was reduced to only 11% of the long-term average. So after those disturbance events that we're seeing, those bleaching events, it severely impacts the capacity of the reef to regenerate itself. Now, these figures that I've mentioned here relate specifically to the Great Barrier Reef, but the severity of this risk holds for all our coral reef systems, including those in Western Australia. In addition to these impacts of climate change observed in the tropical systems of Australia, we've also seen declines in kelp systems, again driven by warming and by heat waves. And on our East Australian current, the climate-driven extension of the East Australian current, which is a more nutrient-poor current system. So the state of the kelp forest is affected by the warming, by the change in current system, by marine heat waves, and also by overgrazing of herbivore fish and urchins that are moving into these temperate regions. So as the water warms up, new species from tropical systems move in and are literally eating a large amount of the kelp. Less than 10% of the giant kelp remains along the Tasmanian coastline, and this is or was a major foundational habitat for many other species of cultural, recreational and commercial importance. Giant kelp are already federally listed in Australia as an endangered community type. Marine heat waves along the Western Australian coast also led to a 100-kilometre range contraction of kelp forests on that side of our country. And in fact, across Australia, loss of kelp species, cumulative loss of a range of kelp species has led to losses of over 140,000 hectares of kelp forests from Australian systems. Brendan mentioned at the start that climate trends and extreme events have combined with exposure and vulnerabilities to cause major impacts for natural systems, with some experiencing or at risk of irreversible change in Australia. And over that 2011 to 2017 time period, extreme events have led to abrupt and extensive mortality of key habitat-forming organisms over 45% of the Australian coastline. Now, corals and mangroves around northern Australia and the kelp and the seagrass around southern Australia are of critical importance for ecosystem structure and function, for fisheries productivity, coastal protection, carbon sequestration, and these ecosystem services are therefore extremely likely to decline with continued warming. But the impacts of climate change in our natural systems are much more pervasive than that. Species on land and in the ocean are shifting polewards. In the northern hemisphere, they're shifting north. In the southern hemisphere, they're shifting south. And species are shifting to higher elevations on mountains and to deeper depths in the oceans. So climate change is leading to a redistribution of life on Earth with many flow-on effects for our natural systems and the human communities that depend on them. The Australian coastline is no exception to that trend, and there's been documented climate-driven changes in many species, including the new occurrence of diseases, toxins and viruses. And one example there is the first occurrence of the virulent virus causing Pacific oyster mortality syndrome, sorry, not enough sleep, in up to 90% of the farmed oysters that died in impacted areas. But we've actually seen changes in the distribution of almost 200 species, climate-driven changes in distribution of almost 200 species, particularly in those regions that are warming the fastest. And this is one of the key messages from the IPCC Working Group 2 report as a whole. That is, globally, about half of all studied plants and animals are already shifting polewards to find conditions that they can survive in. In terms of projected risks for marine systems, even temporarily exceeding 1.5 degrees of warming will result in severe and potentially irreversible impacts, especially in nature and in particular in the Great Barrier Reef. The Great Barrier Reef and for other already severely impacted systems, the risks increase for every small increase in warming. Globally, bleaching conditions are projected to occur twice each decade from 2035 onwards and annually after 2044 under a high emissions scenario and annually after about 2051 under a low emissions scenario. Further ecosystem degradation and loss will threaten livelihoods, coastal protection, cultural values, and if bleaching persists, an estimated 10,000 jobs and $1 billion in revenue would be lost each year from declines in tourism alone. If we move to adaptation and looking at limits to adaptation, limiting warming to 1.5 degrees is insufficient to prevent more frequent mass bleaching events, but it may reduce the occurrence of warming events, similar to what was experienced in 2016 by an estimated 25%. So it will reduce the occurrence, but perhaps not the severity. Reducing other anthropogenic pressures on the Great Barrier Reef can help improve natural adaptive capacity, but adaptation efforts like coral restoration, for example, may slow impacts in small discrete regions or reduce the short-term socioeconomic ramifications, but it will not prevent widespread bleaching. Reducing emissions and reducing the temperature is the only way to prevent widespread bleaching. In terms of kelp, adaptation options include minimising other stresses, local restoration and transplanting of heat-tolerant types. And it's very important to recognise that preservation and restoration of vegetated coastal systems will help foster resilience. However, those risks from climate change remain. It's not a permanent fix. If we shift quickly to fisheries and aquaculture, so fisheries and aquaculture, along with forestry, tourism and agriculture, are sectors that are directly exposed to climate. Adaptation is occurring. For example, there's use of seasonal forecasts of environmental conditions to improve decision-making and risk management and business planning of many fisheries or some fisheries. And further adaptation could absolutely occur, but there are potential social and economic adjustment costs. For example, to adjust and adapt to shifting stocks that are moving large distances. And there might also be potential for disruption to supply chains. Most importantly, less than a quarter of our fisheries management plans for Australia's most important fisheries, and that was an assessment of almost 100 economically, ecologically, socially important fisheries around Australia, less than a quarter of those consider climate change in their fisheries management plans, and those that do consider it only consider it to a very limited degree. The good news is that some stakeholders are already autonomously adapting, but planned adaptation is very patchy and needs much more work to be done to ensure thriving industries and systems. And we also need to ensure that that planned adaptation and the autonomous adaptation are occurring in synergy. And I'll finish there. Thanks very much, John.
Thank you very much too, Greta. It was fascinating. Certainly illustrates just the pervasive effects of climate change across all those systems. So thank you very much. And now to our final speaker, Professor Lauren Rickards. Lauren is Director of the Urban Futures Enabling Capability Platform and co-lead of the Climate Change Transformations Research Group at RMIT University. Her work examines the social, cultural, and political complexities of disaster response and climate change adaptation. She's a lead author of the Australasian chapter of the 6th Assessment Report by the IPCC's Working Group 2. Welcome very much, Lauren.
Thank you so much, John, and thank you to my fellow speakers and everyone for making the time to be here. I'd like to start by acknowledging the Wurundjeri people, the traditional owners of the unceded land on which I'm coming to you here in Melbourne today, and pay my respects to their elders past, present and emerging. So I'm one of the social scientists involved in our chapter, and I think it's worth noting that there's many of us social scientists involved in the chapter and the report as a whole. And the reason for that is that because many of the changes that are significant here are not only those in the climate and physical systems, but of course also in many non-climatic systems as well. So let me take you through in a little bit more detail some of these factors that Brendan touched on briefly at the start. So first among these, I want to highlight is exposure. Now, as a geographer, I'm pretty excited about space, and I want to highlight the importance of thinking spatially and in terms of place, and acknowledge that there's many, many factors that shape our places, climate and weather being one of them, but also many others. The other thing about exposure that sometimes we overlook is that, of course, we don't live in bounded containers unless we're in lockdown in Melbourne. Most of us are pretty mobile. And so when we think about what we actually need to adapt, we need to consider all of the different places and spaces that are important to our well-being and functioning. And some of those we're, of course, not even aware of. Which brings me to the third aspect of exposure, which our report really highlights as important, which is, of course, our location within systems and networks. I'm talking here about the sort of systems and networks that we're dependent on for our mobility, but also our electricity, our financial operations, our mail, our groceries, the digital connectivity of the sort that allows us all to meet here today. So we need to consider the way in which climate-related hazards are exposing all of these different infrastructures and systems, supply chains and other networks to impacts. And that's part of the complexity that Brendan talked about. So when these systems work well, of course, they can be an important source of adaptive capacity and sometimes even provide lifelines during disasters. But when they fail, often catastrophically, sometimes due to stresses and disruptions far from where we're located, they, of course, trigger their own waves of far-reaching impacts, including those between different types of infrastructure, becoming the disaster themselves. So we can think now of the terrible blackouts and other water sewage treatment plant issues that are being experienced in southeast Queensland, northern New South Wales as a result of the floods. And, think too of the colleagues who are unable to make it to this webinar here today about climate change impacts because they're busy dealing with the cascading effects of such impacts on their communities and infrastructure right now. So that brings me to the second non-climatic factor that contributes powerfully to climate change, which is, of course, that question, that big bucket called existing or social vulnerabilities, which is everything else. So some of these are structural and well-known vulnerabilities. They include all of the recognised sources of social disadvantage, inadequate resources, insecure employment, etc. These definitely have to be part of our adaptation portfolio. Others are more context-specific, finer-grained, more contingent. We need to think about these as well. Anyone who's been dealing with the COVID-19 pandemic, which is to say all of us, are very aware of these sorts of contingencies and the way they can hamper our ability to function, let alone do something as serious as adaptation. And so that brings us to our final crucial factor, which is, of course, what we do about it. And so when we think about what the adaptation challenge is, we can think of it as trying to outpace the effects of climate change on all of these different factors, not just the climate per se, but also the way it's expanding exposures of various sorts, the way in which they threaten to deepen inequalities and other vulnerabilities. So this is the sort of approach we need, and this is why we emphasise very much the complexity and need to think through systemic interconnections in the report. And very much highlight that it's not just inadequate levels of adaptation, but it's the question of how we do adaptation that we need to think carefully about. So what are we doing and what do we need to do? Well, fortunately, since 2014, 7 years ago, when the last report was released, there's many new initiatives have emerged. State and local governments have been especially active. For example, I'm closely familiar with the Victorian government's new approach, which involves 7 different systems, taking that sort of systemic approach that's needed. At the same time, there's many great place-based initiatives that are emerging, including at larger scale, such as the regional scale. Some, for example, such as the Goulburn-Murray Resilience Strategy in Victoria, represent the coming together of new alliances, the opening up of new conversations and considerations about what the region could be, and new ways of working together. In the private sector, we see a rapidly increasing awareness of the need to responsibly manage and report on climate risk, increasingly recognised not as an ESG type consideration, but a basic aspect of good business, as in sound management. It's also vital to note here that the sort of autonomous adaptation that Greta mentioned in the fisheries industry, for example, is occurring in many, many different parts of society. And that some of the most innovative adaptations probably happening at that grassroots level, far beyond the radar of any researcher. So one of the challenges with the IPCC report process is that while it pulls together an immense amount of information, in doing so is able to draw very clear and robust conclusions, these conclusions are reliant on the right research being done and being available, and also being done in a timely way. So just as many climate change impacts remain undocumented and below what we're reporting on here, so too do many adaptive responses. So what this means is that to take the report as necessarily an underestimate of both the problems, but also the solutions that are emerging. So when we think about what's needed, there's a real challenge in terms of the what, who, and the how. And in terms of thinking about the way to progress adaptation, it's very much about taking on board the sorts of complexities, cross-sectoral, cross-jurisdictional sort of connections that we point to. This is hard work, which is why we haven't done it to date, but we need to understand that doing adaptation in too bitsy a way, too short-term or hazard-focused a way is simply not going to be adequate. We urgently need more robust systemic risk reduction. We also need serious measures to reduce social vulnerabilities. That means reducing the sort of negative pressures that you've heard about so far today, as well as all the other ones that we know that afflict society. We need to respect the interconnections that allow our systems, landscapes, and communities to be resilient. So while we do need more climate modelling of the sort that, for example, important work in improving design standards, for example, relies on, we also need a whole lot of other new knowledge. We need understanding of how our current systems are set up and why, and how we can best alter them to reduce inequalities and embed resilience. We also need to think about the myriad non-climate change benefits that we could be pursuing and understand adaptation as a tool. So just as decarbonisation implicates everybody and every human activity, so too does adaptation. So if your work contributes to society's positive functioning, and I'm sure it does, then all of you need to adapt so that your work can keep playing a positive role in all of our adaptation. At the same time, we have to be aware that this is not just about protecting everything and every activity that exists today. Climate change adaptation can't just slot easily into existing software packages or as another line on our existing risk registers. We actually need to ask hard questions about our existing systems, our existing trajectories, and our existing goals and institutions. As Brendan indicated, one of the key risks that our assessment identified is actually the risk that our institutions fail to adapt. We mean that both in terms of formal institutions, but informal institutions like norms. What that means is that we really need to work hard at the big picture as well as the micro picture that proliferating climate change impacts keeps drawing our attention to. Part of the challenge is that adaptation is inherently conservative. It tends to start with the proposition that we need to secure everything that exists today. So we start with our accustomed groupings, our accustomed organisations and boundaries. But as we've seen, the proliferation of cascading impacts means we need to think about adaptation at other scales and in terms of other entities, supply chains, subsectors, networks. We need to ask about what we're doing with these systems and how we could perhaps deliver the essential services they provide in different ways. So innovating how we're organised and how we're functioning is going to bring in a more diverse range of voices. This is about being more inclusive and valuing participatory processes. They're always a bit more risky, but everything we're doing in adaptation is necessarily an experiment. So it's vital we embrace that and take a learning-oriented approach, one that deliberately sets out to capture the new insights, including lessons learned about how not to do things, and accelerate understanding so that we can adjust as needed and accelerate progress across society. So all of this takes resources, budgets, of course, but also staff time, emotional energy. Perhaps the major barrier to adaptation is the need for serious upfront and ongoing investment, despite the fact that we know adaptation saves dollars, time, and stress in the end. And so what do we need? Well, as many of us have indicated here today, we need to start adaptation in a much more serious, committed way today. Delays in adequate adaptation are only going to proliferate the impacts and lock in the inevitable major adjustments that are down the track. They'll also trigger a range of liabilities and potentially unmanageable costs, which may be slightly more motivating. Worst of all, it will also undermine our ability to function because adaptation is needed to enable mitigation. And like an oxygen mask, it's needed to enable future adaptation. At the same time, mitigation, of course, is vital to actually giving adaptation a chance, or we'll get to the point where the impacts simply can't be managed. Now, this is all pretty heavy, but I want to emphasise that this is not just about negating negatives. Adaptation is actually an amazing opportunity, a once-in-a-lifetime opportunity, once in a millennium, to improve on the past and present, to enhance our well-being, to restore the planet, and to actually generate thriving communities and ecosystems. So when we think about what adaptation means, perhaps think about how we can surface the immense adaptive capacities that already exist across society. We have so many tools that haven't been recognised, often because they exist within marginalised groups: Australian Aboriginal and Torres Strait Islanders, older Australians, younger Australians, rural communities, migrant groups, frontline staff. We need to listen to everybody so that all of us have a chance to find the adaptive capacities that we're not even aware of and exercise them in every aspect of our lives. Thank you.
Thank you very much, Lauren, especially for finishing on the possible positives there of adaptation and the opportunities that it presents. We now welcome back, I think, all of our speakers to answer some questions from the audience and to have general discussion around the report. So if Brendan, Francis, Greta and Lauren can just join us all together on the screen. I'd like to thank you all very much for your presentations today and now have some questions from the audience. if we're all there. Perhaps, Lauren, first for you, just following up on the adaptation questions. I suppose, simply put, how does climate change adaptation differ from normal risk reduction, including disaster management? Or is it really just normal risk management, risk reduction, taking into account climate change, which hasn't been there before? Or is there a fundamental difference somewhere?
Yeah, absolutely. That's a great question, John. So adaptation nests disaster risk reduction and all the vital work that goes on in that space in a broader framework that has a more continuous time frame. And when you have that more continuous time frame, what you see is that not only do you have to do more work before and after disasters, so that prevention piece and that recovery piece, so that we don't get those residual risks and residual impacts that simply accumulate over time and start to weigh us down. But also we have to understand that all of that needs to actually ratchet up and also become more systemic and more interconnected. And so it's about seeing disaster risk reduction as an important starting point, building around that and from that, but also recognising we're going to get to the limits of some of our existing approaches to disaster risk reduction and have to ask some difficult questions. So take, for example, fire risk, bushfire risk, which is escalating in this non-linear way. Yes, we need more fire resilient trucks, but we also get to the point where actually we're not talking about fire trucks anymore. We're talking about a whole different paradigm of fighting fire. So it's those sorts of ways in which we need to start with our adaptive capacity there in the amazing emergency services and disaster risk management community that Australia has. We really are world leaders in that. And we need to build on that, bring in other voices, look at other ways of doing things and stretch out across all the different sectors.
Thank you very much, Lauren. Any other panelists like to add to that particular discussion? If not, I think we've got one we might pass across to you, Brendan. The report states that a significant increase in adaptation effort is now required, but what does that really mean for federal and state policies and programs? You know, how proactive versus reactive should some of those federal and state policies and programs be? You're on mute, Brendan, I'm afraid.
Thanks for that. I think after 2 years of Zooming, we would all know to unmute ourselves. Yeah, I mean, that's a very important question. And at a federal and state level, there's a number of things that are happening and that need to be happening and that need to be upscaled. But, you know, one is that we need to be integrating into strategic planning at all levels of government, climate change risks. And there's a number of programs underway and there's a lot of action on this at the state government level. We're involved with the Queensland government in a program called Queensland Climate Ready, which is helping each of the state departments to helping them identify what their climate related risks are and how these can be integrated into their climate risk management system. And one of the incentives for them to do that is that Paws and Moody, who do the credit rating, have told state governments, all state governments in Australia, that they are including in their credit rating, which determines the cost of money that they borrow, how they are recognising and managing their climate risks. So the climate risk framing provides one important avenue and way of integrating kind of these strategic or climate related issues into the strategic planning of both federal and state government. So that's part of what Lauren said before about we all need to be doing this.
Yeah.
Federal and state governments need to be doing that themselves. So that's the first thing I would say. And that also applies equally at the local government level as well. And we might, if we've got time, we can talk a bit more about what that might mean at the local government level, given what's happening now with the great flood event. But of course, the federal and state governments also have a role to play in addition to getting their own houses in order in terms of policy and programs. And if I may be a little bit policy prescriptive here, I'm going to have to take off my IPCC author's hat because we're told to be policy relevant, not policy prescriptive. But I think it's a fair. I would hope my fellow authors will permit me some largesse here. But we certainly need to get over this any confusion or debate or discussion about who's responsible for what. I mean, this really requires joint. That's not the issue. The issue isn't what's federal responsibility, what's state responsibility. Of course, that's important. That's not where we need to be. Where we need to be is how, given what our responsibilities are and what our resources are, how can we have more joined up planning? How can we have more joined up capacity? How can we have more joined up effort to reduce the vulnerabilities that Lauren spoke about, to address the impacts on our natural systems that Greta spoke about, and to bring about the reforms in water management that Francis spoke to. So really the challenge here for our governments is to how to have better cooperation and collaboration and joined up strategic planning programs and policies.
Thank you, Brendan. I mean, that's absolutely spot on, but we all know that for any issue that's a long-term issue, the short-term election cycles of 3 or 4 years don't exactly help in that, the government's politicians tend to look at the short-term aims, etc., and short-term outcomes rather than the end game. Do you think that at present, as we sit here now, that the global acceptance, in a sense, that climate change is something we need to deal with and deal with now, do you think that's having an influence on our politicians at all levels, in that they see it as a more immediate thing they have to deal with rather than something that can be put off till after the next election?
Yes, I think so. And that, to bring it back to our report, the Working Group 2 report and our chapter, that's one of the main findings from the assessment. Let's keep in mind that over 34,000 scientific publications were assessed for the Working Group 2 report, right? By over 270 experts from over 60 countries, working very dedicatedly over the last 4 years. And the evidence is very clear that climate change is not something for the future. It's not something that might happen in the future. It's happened, it's happening, and it will continue to happen. And it's a reality we have to deal with. So what I would like to see, and I know many of my colleagues would, is that dealing with climate change from a public policy perspective gets elevated, if you like, to where other issues of national security are, like defence, and I would even suggest health. So whilst in Australia we might argue about how big the defence budget should be and who we should pay to build our submarines, everyone agrees we need to be spending a lot of money on defence. And similarly, we have a very broad base of support for our healthcare system in a general sense, that we compare it by contrast to to the USA system. So that's I think is what needs to happen. We need to be elevating climate change, the climate change crisis, into that same sphere of being a national security issue for which there's bipartisan support.
Well, good. I mean, I couldn't agree more, but this take a lot of work. We even look at, even when you have an acute challenge like the recent pandemic, you still had various levels of government sort of shifting blame around, and it started out with a little bit of all working together, then it quickly evolved into, well, he or she hasn't done that right, etc. So we do have a real challenge, I think, with getting the politicians to collectively come on board, but it doesn't mean we shouldn't keep trying, and hopefully it's getting there. But I suppose I was just looking for a feeling that things are getting better in that respect than they were perhaps a couple of years ago.
Yeah, well, where well, they are, and there's evidence in our report that they are, that Lauren spoke to, because we're seeing everywhere else in the country, in every other sector, people responding. You know, farmers and sectors are responding, you know, autonomously, you know, aside from whatever governments are doing. The insurance sector is moving, the finance sector is moving, local governments are moving, state governments are moving. We're seeing equity and private capital, you know, shifting around in response. So the landscape has changed. I think the Australian economy is rapidly changing in response, and we're seeing through all dimensions of Australian society a greater understanding that this is the new reality we have to do. And this is what I see is, you know, the primary role of the IPCC. It's a science-based activity. It has to be policy relevant. It's not policy prescriptive. We're providing the evidence for what options work, what options are more effective under different contexts. But, you know, that information is there for governmental policymakers, but also for decision makers in the private sector and in the community. And really, it's something that requires a Team Australia approach, if I may appropriate a slogan from across the ditch in our New Zealand colleagues.
No, thank you, Brendan. I think you highlight well, of course, that as we all know, the politicians follow what the voters think. So it's so important that the community, as you point out, private enterprise, just the general community, the different groups you talked about, if they all get behind it, government will, if not reluctantly, will follow. So very good. Perhaps you might move just slightly to slightly more specific. Got a question here for Francis. Francis, how can the water resources in the Murray-Darling Basin really be adapted to climate change? I mean, there's a lot of challenge just getting those resources agreed to by the various interest groups at present, but let alone when you layer climate change on it. Any thoughts around that?
Yeah, John, I wish I had a one simple answer. Unfortunately, it's a lot more complex than that. I think you would argue that there's some examples of clear examples of adaptation happening already, like the reforms with the basin plan I spoke about, are returning an equivalent of 1/5 of the water environment and things associated with that, like water markets, increasing water use efficiency, and so forth. I think you find that, yeah, apart from trying to rebalance the water use between consumptive and environmental water use, there are efforts to try to squeeze as much as we can out of the same amount of water to get more outcome of the same amount of water. In fact, you could say that globally, where I travel as a hydrologist, a lot of water resource management, example in the Murray-Darling Basin, is held almost at a gold standard about how reforms are done and so on. So that's the good news there. The problem is we still got to do more despite doing all this because unfortunately, we live in an unlucky part of the world in the southern hemisphere, mid-latitudes, where you get drying happening into the future. So if you think about it, potentially the water that we recover for the environment is smaller than the impact of climate change. So there are all these challenges here. And John, I think you mentioned earlier on about hazards and so on, about whether is climate change just another layer on how we manage our stuff. I think short answer is possibly yes, but it is another layer that certainly we need to consider. And possibly, as Lauren mentioned, might be another layer that might need us to change the way we live also, because what we want and what we're used to might not be possible, because you're going to have, in this case here, less water in this context. So, there are positive efforts, and I think those will help buffer us against the droughts that we see. But unfortunately, we still got to do more, and we got to make sure that we do more in a way that is not maladaptive too. So this is about the more we do to keep us wanting to live the same way, might actually be perpetuating unsustainable water and land use under climate change with less water, or we got to deal with some of the equity in water sharing social inequalities to solve all those problems also in this context.
Thank you, Francis. I mean, other panel members, please interrupt or say anything you want to address any of these things. Just to try to move it along, I'm trying to sort of direct some of the questions as they come in. But Francis, while we're still on water, I think it's very topical, of course, and I'm sure the question will be floating around in the general press quite a bit. But how directly can the floods that we're witnessing in northern New South Wales be attributed to some effects of climate change? Is there any quantitation to that at all?
So I think I could speak to it in the same way. It's probably the same answer to the droughts and the decline in water resources as well as in the floods. So in the context of the floods, there's no two floods which are the same because there are different drivers and so on. And in this particular flood, in the Brisbane flood, I think we are unlucky from the weather systems where you got a low pressure system sitting and not moving away. It's stationary for a long time. Now you have floods in 74 also, but obviously Wivenhoe Dam wasn't there. And then you got floods in 2011, and then you got these floods here. All of them are bad. Now we can't attribute a single event to climate change. I mean, can blame climate change for everything. But what we do know is your extreme rainfall will be higher in the future. So any flood that we see, it will progressively see worse and worse floods under climate change. So will flood risk increase under climate change? Absolutely. Is this flood caused by climate change? Well, we can't attribute single events to flood. Just like it's the same thing with my response to the water resources too. So we'll see wet years, we'll see dry years, we'll see long wet periods, we'll see long dry periods. But with the decline in the averages, like in the southeastern Australia, you see the droughts more frequently. And that is a challenge because systems have to cope with it and systems have to recover from. So the window of time for you to recover from is less, particularly in the natural systems.
I suppose, Francis, I'm just following up on that a bit. I mean, given that Australia is a very big country, and if I understand your predictions on some of those diagrams you showed us, that we might expect perhaps in far north more rainfall even, and far south less rainfall. Does that suggest that infrastructure-wise we should be planning even more to somehow distribute that better or harvest it better from what we get more in the up north and somehow distribute it down south? I presume that comes into all the planning that goes on with infrastructure.
Well, there's certainly the thought in Australia around potentially developing Northern Australia and whether it's sustainable or not. So that's clearly a subject that the governments are considering. But that's probably a story for another day. But you're absolutely right with the projections. So a lot of these projections of drying is really related to the change in weather system causing your winter storm tracks to move further south. So it's really a winter rainfall problem. The problem is in southern Australia, most of the runoff is generated in winter. So that's why you got the projections of a drying in southeastern Australia, and that's where a lot of people live and lands are productive. Now we are less certain in northern Australia, and you get tropical systems, convective systems that could actually bring more rain in summer months. So it's very much the drying is very much a southern Australian problem. Floods is more probably everywhere, but less so in the south because of the drying we just spoke about also.
I must admit, I've been in Melbourne a few times, but a bit more drying wouldn't hurt. But
I think Lauren had something.
Sorry, Lauren.
Yeah, no, I just wanted to compliment with what Francis was saying, which is, when you think about the impacts of the ongoing floods at the moment and those impacts at different scales, including individuals, households, and what it means for them and the consequences which are unique to them and those neighbourhoods and communities, you could argue that climate change has contributed to those impacts to the extent that prior extremes and stresses with a climate change related aspect to them, and I'm thinking here in particular some of the extreme events, the fires, previous floods, have actually undermined people's adaptive capacity, created vulnerabilities there, which mean that the consequences of these current floods are deeper. And so I think it's really important to just keep that in mind as well as the kind of more climatic or water-focused approach, because it's both aspects. It's so important.
John, I might just add in there for the general public, the understanding around acute and longer events type things. So things like floods are actually an event that happen over a couple of days, maybe weeks and so on, impacting there and then. Fires a bit longer, but the droughts is really a long, slowing event which happens over maybe months, years, and so you got lack of water for 1-2 years. You worry about it, whereas floods is more an event thing that you got to manage from a disaster management perspective. But that can sometimes be confusing for people trying to understand why is there more droughts and more floods. They're really different things at different scales, different temporal scales.
I understood. I think, Lauren, it was like I think you made the health analogy about chronic and acute disease. And I suppose it's a bit like if you look at the recent pandemic, I mean, that was a very acute event. But if you were already chronically immunocompromised, it was a lot worse for you than if you were normal. Same sorts of analogies. The baseline has changed. Brendan, sorry, if you want to say anything else, but just while we're on the floods, and you shared with us the image of in Lismore huddled on the rooftop under the solar panels, etc. What does it mean to you to be working on a report examining the impact of climate change as you experience yourself directly, personally, in a way?
Yeah, that's a good question. So that photograph is from an extended family member of mine who he's on his roof, and his neighbours are also taking shelter on his roof, and you can see the flood level behind them. They were sending these texts and images as it was all happening yesterday morning, and it's Monday, wasn't it? Today's Tuesday. Yeah, yesterday. And they were texting me those photographs because I just live on the nearest relative to them, southern end of Queensland, whilst we were doing this media briefing yesterday. I mean, it was, I had rain pouring on my roof so I could barely hear, and I had texts coming from south of the border with those kind of photographs. So yeah, I mean, this is many Australians during the 2019-20 bushfires, and now in the great floods we're experiencing now. This is their daily, this is what people are now experiencing. But what it makes me, and I should add, the only impact I had when the system went over was I've now got a very large tree blown over in my swimming pool, so my morning exercise routine has been halted for an unknown period of time, because there's a lot of trees down that are in a much more serious situation that people have to prioritise. But for me, the Lismore situation is that, there's a lot of messages here in terms of vulnerability and adaptation and strategic planning, particularly that local government level. I mean, here we have a community and a local government authority and even a state government who are very experienced in terms of disaster risk management for floods, because Lismore has a long history of floods. So what happened this time, and of course, this is unfolding. We have to be careful in being. I'm not saying this to be critical of anyone, but what we have in place is an unprecedented flooding event that exceeded all previous levels. So my own extended family member, they got the warnings. They moved their cars and vehicles above the maximum known flood level to a friend's house, but it got flooded. So it's not that they weren't prepared. It's not that they didn't act on the information. It wasn't that they weren't given information. It wasn't there. I mean, there was a levee there. There'd been a levee built as an adaptation response. But what we're seeing is climate change has just raised, there's as we said, there's been, in our report, as Francis says, we're not attributing every event to climate change, but there has been about a 20% increase in the intensity of rainfall events since the 1960s, and that's projected to increase. So we can expect more intense rainfall, and what that means is we can expect, flood levels to be more than what they were. So from a strategic planning point of view, what does a city like Lismore do now? You know, when even with good planning in place and good emergency services and warning that was sufficient for people to respond, that it was still overwhelmed by the magnitude of it. So this is why I keep coming to the need to bring to have this climate change integrated into strategic planning at the local government level. It's no longer an optional, it's an option, it's a necessity.
Yeah. Brendan, I mean, related a bit to that, we've got a question here really for the whole panel. If this meeting and your report had been sort of held 30 years ago, how could we have prepared for some of the extreme weather we're seeing today, such as these floods? What could we have done if we knew all this 30 years ago? I think you've sort of touched on that extensively, Brendan, but that's the question. I mean, I suppose how prescient can we be with these things?
Well, I think Lauren, I'd like to hear Lauren's response to this, because she raised this issue of adaptation and this issue of exposure. And she talked about exposure in terms of you could be geographically exposed, you could be exposed in time,
yep,
which is what Francis alluded to, and also about being exposed in terms of the system you're in. So I think it'd be nice to hear from Lauren on this point.
Yeah, absolutely. And just to pick up on that, I mean, I think to give you a comprehensive answer, John, we'd be here a while, but yeah, look, I think we have had an extremely strong belief in the benefits of large connected infrastructural systems. It's kind of an icon of modernity, if you like, and we all benefit from them. However, I think we're also starting to see the limitations of those and the weaknesses of those. And so perhaps one thing we would do differently would we actually have more decentralised infrastructural systems, more modular approaches of the sorts that systems thinking, resilience thinking now encourages. And of course, you know, everyone would understand that there's very strong synergies here with the shift to renewable energy in the energy sector, for example. So, I mean, that's an example. Likewise, you know, stronger flows of information, which includes building in redundancies. We've become highly addicted to the kind of just-in-time management approach in business, in supply chains, often in just about every organisation. I think academics live that as well. And again, you know, that's all fine when everything's sailing along, but we need redundancies. We need you know, safety nets, etc. So, I mean, that's just two sort of fairly abstract senses in which I think we would build our systems and develop as a society differently. And then, of course, there's all, you know, very clear exposure questions about where we would build and wouldn't build, because it's a whole lot more difficult to move settlements, including cities, ports, etc., than it is to build them properly in a safer place in the first place.
Yeah, a bit of forward thinking. Look, we have another question here for the panel that relates, I suppose, very closely to that in a way, which is governments across the world are sort of tapering off their spending and moving towards fixing various deficits that they have. But the advice seems to be that they will need to invest in climate mitigation adaptation sooner rather than later. So are those two compatible? How should they rethink or prioritise their spending or the way they do fiscal policy? It covers a broad, difficult question.
I mean, I can start, but I think
yes,
all my colleagues have something to say here. So yeah, we need to get the economic evaluation right.
Yeah.
So I think that's one thing we have to do, because there are costs arising from inaction.
And costs from the inaction too. Yeah.
That's what I mean. There's costs from the inaction. You know,
yeah.
The failure to adapt will lead to greater costs in the future. So those costs can be avoided. So we need economic valuation, including microeconomic valuation, that can take those factors into account. And I think we also need to bring in the mitigation side, because we're used to thinking about, you know, the cost of carbon in terms of carbon as like a traded commodity. But there's another way of economically valuing carbon, and that's the social cost of carbon, right? And that's the avoided loss and damage from avoiding emissions. And that's, again, it's well established now in economic theory and practice. So I think, one thing we have to do is do the costs and benefits comprehensively and properly, and take into account the cost of inaction, the opportunity costs, the benefits we get from the ecosystem services that would be lost, for example, in the Great Barrier Reef that Greta mentioned too, etc. So, one of the problems we have, for example, at the moment, we don't have ecosystems as an asset in our national economic accounts.
Yep.
We don't assign an economic value to the services that they provide and the benefits to our economy from them. So we need to be factoring all of those things in. We need to be factoring in the social cost of carbon and failure to mitigate. And we also need to be definitely looking at the cost of inaction from failing to take the necessary adaptation when the information is clear about what the risks are.
Thank you, Brendan. Any other comment on that, Lauren?
Oh, just to reinforce that one of the clearest needs and one of the clearest routes to positive adaptation is to stop generating problems, stop generating vulnerabilities. And so, whether that's generating ill health, whether that's generating ecosystem degradation, stopping those actions is one of the most effective things we can do. And while, arguably there are costs involved, that it's also a kind of a win-win type approach. I'd also just like to flag that, this is not simply, a fiscal question. There's a lot of investment needed that goes beyond those straight out sort of accounts. We're talking about time, mental energy, giving the effort it takes to go to that next meeting where you are with your colleagues and you are going to have a case to put forward about why you think climate change adaptation ought to be considered in that particular piece of work. All of us need to kind of commit to doing those sorts of things so that across every sector, every profession, every organisation, we start adaptation as needed.
Yep, I agree.
Well, I just had a text message from Greta apologising for dropping off. She said that she's completely lost internet connection in their town. She thinks in the whole region. And so she was just able to send me a text on her mobile phone explaining why she disappeared from the Zoom, from our webinar.
Yep, understood. Well, I think she's still on the line on audio. If she is, she can have the last comment at the end. But just back on that last point again, Lauren, I suppose it's my background, but using that health analogy again, I mean, socially and economically, prevention is much better than cure, than treatment. Prevention is always better than treatment. Look, we've got time. There's one last question now, I'm afraid. It's a question for the panel. Does the panel agree with the New South Wales Premier's description today of the current floods being a 1 in a 1,000 year event? I suppose what's behind that question is, if it's a 1 in 1,000 year event, does that mean it's just chance, nothing to worry about, won't happen another 1,000 years? Or does it actually provide evidence that the world is changing and things are going to happen a lot more frequently? But what does the panel think about the his description of today's flood as a 1 in 1,000 year event? Comments?
Can I just say that that sort of way of accounting for the character of events is one of the things that we probably need to wean ourselves off, because you have to ask which 1,000 years. If it's the last 1,000 years, it's not highly relevant for what we're talking about now. So I'd suggest an updated way of phrasing that and thinking about it.
Thank you.
I'm happy to have a comment there. I think we need to have a look at the data to be able to say whether it is or is not. But suffice to say, there were floods in 74 and 2011, which were similar as this flood. And just building on what Lauren is saying, whether this is a 1 in 100 year event or 1 in 50 year event under climate change, the 1 in 50 year or 1 in 100 year event will become more extreme, because we just know that from an urban flood perspective.
Exactly. Okay, Greta, if we've got you on the line there, would you want to make any other comments or final thoughts?
Okay, thanks, John. Sorry about dropping out there in a major way.
Sorry, we've missed you. I didn't realise you weren't there.
Well, I've missed the last 30 minutes of the conversation, so I'm not really sure what's been said already, or if there were any questions around marine systems that I might be able to answer.
There might have been a question, I think, Greta, around, perhaps not. Any other thoughts for Greta?
Well, Greta, we just had a discussion about, how we talk about extreme events. Like, there's a debate about how do you describe the current flooding event? Is it a 1 in 1,000 year event, or is that no longer the scientifically correct or policy relevant way of talking about it? So maybe there's an analogous question regarding marine heat waves. How would you?
Yes, there would be. Yeah, we're facing conditions that just won't be anything like what's happened in the recent past. So I'd concur with Lauren's comments around we need to reframe that and talk in a current and a future context, because the past is in terms of patterns and how we describe those is perhaps less relevant.
Okay. Well, look, thank you very much. I'm afraid it's all we have time for today. It's my fault. We've gone a minute over. So thank you to everyone for joining us and for, I thought, what's certainly very enlightening to me anyway, some of the great questions and answers and discussion. For more information and the full report, please visit the IPCC website at ipcc.ch or by scanning that QR code on your screen. You can also follow the Academy's work on this topic by visiting our Climate Change Hub. You just go to the homepage, science.org.au, and follow the link. And as I mentioned, I think earlier, Future Earth Australia is working on a national strategy for just adaptation. It seeks to consolidate and extend a broader agenda of proactive and productive reform of climate adaptation, and recognising that adaptation and resilience must be framed with respect to enabling a just transition for all Australians. So thank you again to our speakers today, Professor Brendan McKee, Professor Greta Petzel, Professor Lauren Rickards, and Dr. Francis Chu. We appreciate you joining us today and really for the enormous amount of work that you've done on the whole issue that you and your colleagues have contributed, and to that report that was released yesterday. We are all in enormous amount of gratitude to you. Thank you all for joining us, wherever you are in the world, and good afternoon.
It's too late to avoid climate change, but we can still stop the worst of its impacts on our lives, jobs, communities, and the world we live in. The Intergovernmental Panel on Climate Change, or IPCC, is the global authority on the most up-to-date information and risk analysis of this challenge. It outlines the impacts of climate change, how we can adapt, and where we are most vulnerable in its 2022 February report. With this, governments and leaders can choose how to act to protect us in future. Professor Catherine Bowen, one of the lead authors, says many risks for human health and well-being could be reduced and some potentially avoided if we reduce our greenhouse gas emissions and strengthen our adaptation responses. So, what are the risks, and how do we prepare for those we can't avoid? Reaching 1.5 degrees Celsius of warming before 2040 will cause further serious and complex threats to our ecosystems and communities. This goes far beyond worsening extreme weather events like flood, drought, and fire. Climate change will also worsen issues that already exist, such as social, economic, and health inequalities. Financial and emotional stress from drought and other disasters can lead to far-reaching effects through rural communities. And extreme heat has already increased global rates of many illnesses. In Australia and New Zealand, the IPCC identified 9 key areas of risk, including coral reefs, alpine biosystems, certain forest types in the south, kelp forests along our southern coast, sea level rises in many coastal areas, agricultural production in much of the country, heat-related death and disease, other complex impacts on our cities, and the inability of some institutions and governance systems to manage climate risk. The report also identifies 127 future issues that will get worse for every fraction of a degree of warming above 1.5 degrees Celsius unless effective changes are made. In agriculture, warming threatens to weaken soil health and increase pressure from pests and disease. Droughts, floods, and heat waves reduce crop yields, making food more expensive and difficult to access. Much of this can be avoided or lessened if we reduce emissions and limit warming. Below 1.5 degrees Celsius, many animals and plant species should be able to adapt to a changing environment. For example, below 1.5 degrees Celsius, sea level rise will be slow enough to give mangroves time to migrate to livable conditions near a new coastline. And that's especially important in places like Northern Australia, where mangrove forests protect people and infrastructure from worsening disasters such as floods or cyclones. Being ready for a changed climate is just as essential if we want to avoid loss of life, biodiversity, and infrastructure. Indigenous peoples also have crucial and unique knowledge and experiences to offer and must be central to decision-making processes. From technology solutions through to simple changes in how we plan future cities, there are many actions available for governments and leaders to put in place to make a difference. The scientific evidence is undeniable. Climate change is and will continue to cause harm to human well-being and planetary health. Any delay in both reducing emissions and addressing the impacts of an increasingly changed climate will mean we will miss this chance to secure a livable and sustainable future for us all.
The Australian Academy of Science, because questions need answers.